All right, so I set a due date for the homework, because we have a lot of stuff to do and we got to move on. And if you need more time, you do have that late pass option for homework assignments. I give you 20 late passes up front, which is enough for, a couple for each assignment. The quizzes don't have late passes, but you can turn those in late. And the applications don't have late passes, but you can turn those in late. The homework, the only way you can turn those in late is with the late pass, because that's a different system that integrates with Canvas. So if you're still working on the application, that's okay. Get it in as soon as you can. All right, what do I want to look at here? This is a good one. So 26 is one that I might want to look at there. Yeah, and one thing you want to do is pay attention if it says do it by hand or use a spreadsheet, because you will not get the same answers on each one there. And 26 is like this one. Okay, so this one compares the by hand method. Oh, interesting, the graph did not appear there. Okay, I'll make a note to fix that. Let's see, message instructor. Frequency histogram seems broken. Please fix. It's not necessary for that problem, but it's nice. Okay, so come on, go away. Oh, my Zoom menu must be in the way. There we go. All right, so let's take a look at this one here. So first on this one, I said use the locator method. And in the previous problem, I linked out to the technique that's listed in the OpenStax book there. And I had a video that explained it too. So I'll just go over that one again. And the point of this one and the problem before was just to understand what the heck is a percentile. So I've got this big list of numbers here. And in any number set, percentiles only work perfectly if there's exactly 100 numbers, and there's almost never exactly 100 numbers. In which case, there's no agreed upon way in the world to calculate what a certain position the percentile is. There's just different techniques. So a spreadsheet does it different than a by hand technique, does it different from a TI calculator, which does it different than professional statistical packages. Kind of a pain in the butt, but they're all in the ballpark. So for the first one, I say, okay, let's just locate the 15th percentile here. So I'm gonna put this into my program. So this is a review of the topics from last week. I want this here. Current page. All right. Let's pull it up a little. All right, so I want to find P15, and I want to do it with the by hand method that was mentioned in the previous problem. Here's my pen. Sorry, I'm struggling here. Here's my pen. Okay, so I want to find P15, the 15th percentile. So that means where in the list can we mark so that 15% of data is at or below that point? All right, so to figure that out, I need to look at how many numbers in the list, and I was given that there were 117. So to figure out the location of the list, I need to find out what is 15% of 117. So 15% means 15 out of 100 times 117. So I got to do that calculation. Calculator, please. Choose. Let's actually bring up a new spreadsheet, because a spreadsheet is a calculator. And let's call this percentiles. Good to give it a name, otherwise you have all these percentiles, all these untitled spreadsheets floating around. And I've got n is 117. I want to find p, I'm just going to call it 15. And now I want to find the location. Right. So for example, location number 117 is the last number. Location number 1 is the first number. So I want to find the 15% location. So then I just take, ooh, I lied. Back, here, here. Based on the way we calculate the median, you always increase this number by 1. So I want to take 15% of 118. And the reason that is, if you just think about a simple set of numbers like 1, 2, 3, 4, and 5, the middle number is 3, right? But I have n equals 5 numbers. To identify the middle number, I want the middle number, which is the 50th percentile, 50 over 100. So I'm trying to find its location. So just an explanation of location here, at least the simplest version of it. If I take 50% of 5 plus 1, which is 6, what's half of 6? Why, it's 3. The third number, oops, I didn't mean to circle that 4. The third number is the middle number in this list. Okay, so that's kind of why we add that 1 there. So back to my calculator. So I want to take 15 out of 100 times parentheses n plus 1. If it comes out to a whole number, you just grab that number in the list. Now this came up to a partial one, so that means the location I want is the 17th location and the 18th location, because it's in between there. So if I look at the list, I got to figure out where the 17th and 18th are. So back to my list. All right, so how many columns do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 columns. Notice that these numbers are in order, row-wise, and then the next row. So this is the 9th one. Underneath here is the 18th one. So red. This one right here is the 17th, and this one right here is the 18th. So the 15th percentile is right in between here. So 15% of the data is at or below that point. And so to find the 15th percentile, P15, I would just average those two numbers, 2, 5, 5, 5, 2, 5, 5, 9, divide by 2. And see what we get. So 2, come here, 2, 5, 5, 5, 2, 5, 5, 9. So let's call this P by hand 15 is going to be the average of those two numbers. Oops, average, boom, comma, boom. All right, so I get 255, 2,557 is the by hand one. Now, if I put the data in here, the spreadsheet's going to give me a different version. So spreadsheet. The point of that problem is just to kind of illustrate what the heck is a percentile. But there's no set way to do it. So let's see, where's my data? So I should be able to copy this into my spreadsheet. Let's put it right here. And then let's just clean that up a little bit. Got them all. So in the spreadsheet version for P15, I use the percentile function. And in class, I mentioned we use either percentile or percentile inclusive, and then just grab the data, comma, which percentile do you want? 0.15, it wants a decimal version of the percent. So it says the answer's 2,574.2. Notice it's a slightly different number. They're in the same region. If we look at those numbers, right, it's below, oh no, it's actually slightly above that number right there. So it's just above the 18th. But the by hand method differs than the spreadsheet method. And if you tried this on a TI calculator, you'd get a different number still, but they'd all be in the same region of each other, just the way it is. So it just marks, hey, at this point, there's 15% of the data is below that point of a percentile. Okay, next question I know people struggled with from the emails I got, number 26. And I am going to do part 1, but not part 2. I have that in other recordings, and this is in other recordings too, but I calculated a bunch of numbers here for you. These numbers are from a spreadsheet. They are not the by hand methods for the quartiles, and quartiles are percentiles. So if you try to find a quartile by hand, you'll get a different answer for most data than if you try to find a percentile on a spreadsheet. So if we plug these numbers into a spreadsheet just to see, like quartile 1, for example, so let's just throw the data in here. Ooh, wrong data, I must not have copied it. Control C, Control V, and then let's just find Q1, which I could use the quartile command or the percentile command, and it just says, hey, where's your data? It doesn't matter how the data is organized or if it's sorted or not, and then I want the first quartile. And so I should get the same number that I already calculated for you. And then let's just get Q3 for fun and answer the question. It wants to know, if we use the box plot, where do we mark what's an outlier? So to do that, we need to know the interquartile range, IQR, and that's always just Q3 minus Q1. And then, let's see, I want the lower, and the lower is always Q1 minus 1.5 times the IQR. Now, I'm just typing this for educational reasons. You don't need to type that, but I just want to remind you what the heck I'm doing here. So if I go up and get Q1 and then subtract 1.5 times the IQR, and once the numbers are on the spreadsheet, right, it's nice, I can just point click. The upper mark for what an outlier is, unusual numbers, would be Q3 plus 1.5 times the IQR. And in other videos, I have explanations of why. This is just how, plus 1.5 times the IQR. So this says if there's any numbers in the list less than 6.25, and these numbers are in order row-wise, so the lowest is 12.5, so there's no unusually low numbers. And if there's any number above 31.3625, that's a little bit high compared to the rest. And the highest one here is 30, so there's no unusual high by this measure of outliers. Usually, oops, high data, or large, however you want to say it. Okay, so for most problems, we use a spreadsheet to do the calculations. I'd had a couple where I had to do it by hand, and the point of that was just to, hopefully that would help you understand what the heck is a percentile in general. So I hope this helped. If not, look me up outside of class, and I'll be glad to try and go over this and help you understand it better. But a lot of these ideas, they just take getting used to. Which means you just got to read about it and try it, and read about it and try it, watch a video and try it. And eventually you get used to the idea. There's very few of these ideas that I get first shot when I looked at them earlier in my life. It took me a while to grasp them. All right, so let's move on.